Hi, this is SB sir. Today I'll teach you enzyme inhibition and the three types of inhibition. First one is a competitive inhibition. The second one uncompetitive inhibition, which is kindly opposite of competitive inhibition, and the third one is a mixture of these two, the mixed inhibition, the mixture of competitive inhibition, and according to the properties, the mixture of competitive inhibition and uncompetitive inhibition, which we say because it resembles both the types, so we say it's mixed inhibition. And a particular case of mixed inhibition, which we call it non-competitive inhibition. It's a particular case. It's a particular case which falls within mixed inhibition. It's called non-competitive inhibition. So summarizing the four things: competitive inhibition, where competition takes place between the substrate and the inhibitor, and the inhibitor looks like the substrate, it resembles the substrate, and it binds and it competes. The inhibitor binds and competes with the substrate, so it's called competitive inhibition. Uncompetitive inhibition, where there is no competition between the substrate and the inhibitor, and the inhibitor will bind to a separate site other than the substrate, and it will affect the enzyme binding to the separate site. Like you're walking with your hands and you are putting I have put a baggage on your back. So that is a kind of uncompetitive inhibition. If with the baggage on your back, you cannot walk properly with your hands because you are carrying a load. So it's a type of uncompetitive inhibition. Mixed inhibition, where it resembles both the types of competitive as well as uncompetitive inhibition. See, if there are two binding sites, and a mixed inhibitor will bind to both of them. Say for the inhibitor, it binds to the substrate binding site. Like competitive, it can bind to the substrate binding site. Like uncompetitive, it can bind to the site which is other than the substrate binding site. The uncompetitive inhibitor can bind to both the enzyme inhibitor in a free enzyme, forming the enzyme inhibitor complex. It can also bind to the enzyme substrate complex to form the ESI complex. So uncompetitive inhibitor is a different type of inhibition. Competitive inhibitor will bind to the enzyme free enzyme only, and it will form the enzyme inhibitor complex, whereas uncompetitive inhibitor will bind to the enzyme substrate complex and forms the enzyme substrate inhibitor complex. So that is the uncompetitive inhibitor. The mixed inhibitor, you see, the mixed inhibitor will have properties of both. And non-competitive inhibitor is when the binding affinity, non-competitive is a particular case of uncompetitive inhibition, where the binding affinity of the inhibitor with the enzyme and the inhibitor with the enzyme substrate complex are equal. So it's a particular case of mixed inhibition. Non-competitive inhibition is a particular case of mixed inhibition.
So what we go straight into the competitive inhibition. What are the properties of competitive inhibition? A competitive inhibition, I just told you, the competitive inhibition is a substrate analog inhibition. That means the inhibitor bears a very close resemblance with the structure of the substrate. The inhibitor is equal to substrate, and it will look like the substrate. So if the substrate looks like this, the inhibitor also looks like this. So it can be smaller than the substrate, but the chemical bonds are actually similar. The structure is also a very similar patterned structure. So this inhibitor, now the enzyme will not know whether it's substrate or the inhibitor. The inhibitor actually resembles the substrate structure, and the enzyme will bind to the inhibitor, and this binding of this inhibitor with the enzyme results in the formation of enzyme inhibitor complex. We put third brackets to signify molar concentration. So this is a substrate analog reaction, and we told you I told you that in competitive inhibition Km is affected. How Km is affected? Because the inhibitor, as the inhibitor binds to the enzyme, there will be the substrate will compete. Substrate will ask, where do I bind? You are sitting on my chair, come on, I don't have place to sit, how will I take food, how will I dine? So the inhibitor, so it's actually the binding of the inhibitor, the binding of the inhibitor with the enzyme has now put on a put all the substrate to question marks. Then that, and when the substrate cannot bind to the enzyme, we say that the affinity has decreased. Enzyme now cannot bind to the substrate, then the affinity has decreased. The Km affinity has decreased means the Km value has increased. The Km affected means the affinity has decreased. Now the inhibitor binds to the enzyme and the substrate will not be able to bind. So we say, we actually from outside what we see, that the enzyme cannot bind. The enzyme cannot bind to the substrate, and so the affinity of the enzyme has got affected, and the Km is affected, and the Km value increases. Increases by what? Increases by a factor, factor alpha. That means in the equation 1 by V equal to Km by V max into 1 by S plus 1 by V max, in this equation we have to now increase the Km value by a factor of alpha. Km increases by a factor of alpha. And what is alpha? Alpha is actually 1 plus I by Ki. Remember that alpha is a factor which is greater than 1 because it is 1 plus something, 1 plus this term, the molar concentration of inhibitor and the binding constant of the inhibitor with the enzyme, the inhibitor with the enzyme. Inhibitor plus enzyme, the binding constant, EI complex, the binding constant, this is Ki. The inhibitor binding constant with the inhibitor, this is Ki. So for competitive inhibition, it is the Ki. Remember that it is Ki. Okay. Before, so these are the another point, it will not affect the Vmax. The competitive inhibitor will not affect the Vmax because when Vmax is actually reached, it is at very high substrate concentration, and at that substrate concentration the inhibitor is simply outweighed. It is simply outweighed. The substrates still we are much more in number. So you get out of this, get out of our pathway and let us bind to the enzyme. So the Vmax remains unaltered. So these are the properties of competitive inhibition. Now let us go into the properties of uncompetitive inhibition. Uncompetitive inhibition. So I rub this out. So let us go into uncompetitive inhibition. So in uncompetitive inhibition, I will again write that equation of the linear transformation of Michaelis-Menten equation. And what is that linear transformation? I just told you in the previous class that linear transformation. So the linear transformation is 1 by V equal to Km by Vmax into 1 by S plus 1 by Vmax, that is y equal to mx plus c. Now how this uncompetitive inhibition, just now I told you that this type of inhibition takes place in enzyme substrate complex. The inhibitor only binds to the enzyme substrate complex. The inhibitor will not bind to the free enzyme. It will not bind to the free enzyme. It will not bind to the free enzyme. Only when the enzyme binds to the substrate, that there will be a particular structural change in the enzyme molecule, and that structural change will allow the inhibitor to bind to the enzyme, and now the inhibitor will form the ESI complex, ESI ternary complex, and this binding, this ES plus I binding to form ESI complex, and this rate constant is Ki dash. This rate constant is Ki dash. So by, and what is this Ki? This is the rate constant of the binding of the inhibitor with the enzyme substrate complex. It is not like the competitive inhibition of Ki. Ki and Ki dash are different, and here and here this the factor alpha is 1 plus I by Ki dash, okay, alpha, and we say it alpha dash. Alpha dash is what? 1 plus I by Ki dash, 1 plus I by Ki dash. So for uncompetitive inhibition, we have learned 2 points: that the inhibitor has no structural similarity like competitive inhibitor, and it cannot bind to the free enzyme. It can only bind to the enzyme substrate complex to form the enzyme substrate inhibitor ternary complex. It will lower. The second point, and these things are included. And the second point is it will lower the Km. It will lower the Km. Why it lowers the Km? Because inhibitor actually tells, come on, enzyme, come on. It actually promotes the enzyme substrate complex formation. Enzyme substrate complex formation. The enzyme substrate complex formation is affected means binding is affected. Binding is made faster. The enzyme binds more avidly to the substrate, means the Km value is lowered. So here the Km value is lowered, and by what factor? The Km value is lowered by Km value, if lowered, and we know that alpha dash is greater than 1, it is 1 plus I by Ki. So how do we treat the Km if it is lowered? Km multiplied by alpha dash, or division by alpha dash. Km multiplied or division. Okay, there is no confusion. It should always be if Km value is lowered, it should always be Km by alpha dash. So Km value is lowered by Km by alpha dash. So Km is lowered by Km by alpha dash. Here we write it down, Km by alpha dash. And what about Vmax? Vmax is also lowered. Vmax is also lowered because if this inhibitor binds to the ESI complex, it will not allow the ESI, the enzyme substrate complex, to act and release the product. The product will never be released. So the Vmax is lowered. So the Vmax is also lowered, and by what factor? The Vmax is also lowered by alpha dash. So the equation, so both this alpha dash Km is lowered, Vmax is lowered. Here also I lower Vmax, alpha dash. So how does this equation change in case of uncompetitive inhibition? I'll just tell you that. I'll just write it down here. It is 1 by y, 1 by v equal to Km by alpha dash into alpha dash by Vmax. So this alpha dash and alpha dash actually cancels out into 1 by s. 1 by s remains plus 1 by Vmax into alpha dash. Alpha dash remains here, and here the alpha dash cancels out. So the equation, because Km by alpha dash and alpha dash goes up, if we multiply it, K alpha dash goes up, alpha dash cancels out. So the equation is 1 by V equal to Km by Vmax into 1 by S plus 1 by Vmax alpha dash. Now if we get to the plots, if we now get to the double reciprocal plots, the x axis, y axis, if we get to the plots, what happens after this treatment, that I will show you for uncompetitive inhibition. For the two kinds of inhibition, I will now get to the plots. Suppose I plot this out. So I draw the y axis, then I now draw the x axis. This is negative x, positive y, negative y. Now, what was the original plot for no inhibition? If you remember, it was 1 by v km by v max into 1 by s plus 1 by v max. So what was when y equal to 0? So y equal to 0, x equal to minus c by m, that you all remember. When x equal to 0, y equal to c, that you all remember for a straight line. So these are the 2 points. This x equal to 0 is actually on the y axis, this point is on the y axis, and y equal to 0, this point is on the x axis, and it is a negative minus, and as the value of x is negative, so this value is minus c by m 0, and this value is x is 0, y c. So what is c? C is 1 by v max, 1 by v max from the original equation. C is 1 by v max, and what is minus c by m? Minus c by m is km by v max. That this is m, km by v max is m, and what is c? 1 by v max. So c minus c by m, or c by m is what? C by m is what? Km by v max, it is m. C by m, 1 by v max into km by, divided by km by v max, the v max goes up, v max by km, the v max cancels, is 1 by km. So minus c by m is equal to minus 1 by km, and this is actually minus 1 by km 0, and this is 0 1 by v max according to double reciprocal plot of no inhibition, and we draw a straight line here. Sorry, this is not traversing those points. So these are the 2 points, and we draw a straight line here. This is of no inhibition. I draw it by green, the no inhibition line, where these are the abscissa and the coordinates, and these are the points on y axis and x axis. Now, what happens in case of uncompetitive inhibition? What happens in case of uncompetitive inhibition? What happens? Let's just guess. The Vmax is now lowered. So 1 by Vmax is the Vmax is now lowered. So Vmax by alpha dash. So if Vmax is now lowered, Vmax by alpha dash. So what we say? The alpha dash goes up here. So now the point C is alpha dashed Vmax. So alpha dashed Vmax, the point is alpha dash Vmax. Now alpha dash is a factor which is greater than 1. So the point should rise above. So there is a displacement of this point from here to here in case of uncompetitive inhibition. Okay. Now what happens to this Km point of view? Km is also what? Km is also lowered. How much Km is lowered? Km is lowered by Km by alpha dash. So when Km is lowered by Km by alpha dash, so Km, how does this happen? Km is lowered by Km by alpha dash. So this point minus C by M is what Km, it is 1 by Km. So it is now alpha dashed by Km. Value is lowered. So by what value? Km is lowered by alpha dashed. So 1 by Km, which is this point, is also lowered by Km by alpha dash minus, now this value is minus 1 by this, minus 1 by Km, this value is 1 by Km by alpha dash, that means alpha dash goes up. So alpha dash is the factor which is greater than 1. So this, if it is greater than 1, so it is the, this point actually shifts in this side, because it has the value has got more negative, the alpha dash Km is more negative than 1 by Km, because if the value is in the negative part of this, the value has got more negative, so the shift is here. So the shift is by this factor alpha dash, just like Vmax, the shift is upwards, and the same displacement for Km for this point. So these are the two parallel points, and for this inhibition, the inhibition line is actually parallel to the uninhibition line, to this non-inhibition line. The red line is actually parallel because the displacement of Vmax by alpha dash is countered by the lowering of Km. This alpha dash Vmax is also countered by alpha dash Km, and this both displacement is towards the increase, and this displacements are same. So because of this equal displacements of these 2 points in the y axis and x axis, these lines are now parallel. The red line is become parallel. So in case of uncompetitive inhibition, if we do the double reciprocal plot, we get a parallel line to the non-inhibition line. The competitive inhibition line will be a parallel line shifted towards the left, and it will be a parallel line to the non-inhibited line. So what happens in case of competitive inhibition, and I will now get to competitive inhibition for this double reciprocal plot. I will just rub this one. Just rub this one, and now I will write the equation for the competitive inhibition. 1 by V equal to into 1 by S plus 1 by Vmax. And I just told you for competitive inhibition what happens is the value of Km is increased by a factor of alpha, So Km now becomes Km alpha, and this Km alpha is more than the value of Km, and Vmax remains unaffected. So these 2 points, this minus C by M point, this minus C by M point is now what? What is C here? 1 by Vmax, and by M, what is minus C? C is 1 by Vmax, M is what? Km alpha by Vmax. Now that is equal to 1 by Vmax by Vmax into Km alpha, Km into alpha. So this Vmax cancels out. So minus 1 by Cm is what? 1 by Km alpha. That is, this point has 1 by Km alpha is greater than this point has increased, this is Km has increased by a factor of alpha, and we tell that this is Km say dash. So what is this Km alpha? It is Km alpha now is is equal to Km dash. Now what is this Km dash? This point is 1 by Km for uninhibited enzyme, minus 1 by Km for uninhibited enzyme, and this point is 1 by Vmax for uninhibited enzyme, this point. Now Km has the value of Km has increased. It is now Km dashed, which is more than the value of Km. If this value Km, if say minus 1 by 2 and minus 1 by 3. Now the Km value has increased from 2 to 3. So is minus 1 by 3 closer to 0, or minus 1 by 2 is closer to? Minus 1 by 2 is 0.5 negative, and minus 1 by 3 is 0.33 negative. So which one is closer to 0? This minus 0.33 is closer to 0. So while the Km value goes from 2 to 3, that means Km has increased to Km dash. So this point has shifted towards this end, and we say that this is the uninhibited line, and this is the so this point has got shifted. I am very sorry. This is the uninhibited line, and this point has got shifted to 1 by Km alpha 0, but that, or alpha goes up, alpha by Km, if I don't write alpha, so alpha by Km 0. So this point has got shifted towards here, and but this Vmax point, the Vmax remains unaltered. So the new straight line for competitive inhibition is like this. It will pass on through the same y-axis point, but the x-axis point will be closer to it will get a rightward shift, to in the x-axis. It will actually cross. It will be actually a cross type of line, and this Km point will be towards the rightward shift. So this is for competitive inhibition double reciprocal plot. Remember, competitive inhibition double reciprocal plot. For uncompetitive inhibition, we got a parallel line, and this is actually the line gets the original uninhibited line gets intersected by a line, gets an intersection by a line where the y-axis remains same, but the x-axis crossing, while it crosses the x-axis, it crosses a point which is closer to 0. So I will rub this out, and I will now go to another type of the inhibition, which is mixed inhibition. That is, it resembles both competitive as well as uncompetitive inhibition. Now I will go to mixed inhibition, that is, these inhibitions which resembles both, competitive as well as uncompetitive inhibition. Remember, I'll again write the equation 1 by V equal to Km by Vmax into 1 by S plus 1 by Vmax. Now is in case of mixed inhibition, because it is a mixed inhibition, there will be two types of inhibition, both types of inhibition. So in case of competitive inhibition, we saw an increase or decrease of the parameters by alpha, and in case of uncompetitive inhibition, we saw the parameters Km, Vmax increase or decrease by alpha dashed. Alpha was 1 plus I by Ki, and what was alpha dashed? Alpha dashed was 1 plus I by Ki dash. Alpha and both alpha and alpha dash were factors which were greater than 1. So now why do we consider both alpha and alpha dash? Because alpha is for competitive type of inhibition and for EI complex formation. Alpha dash is for ESI complex formation, and it is just like uncompetitive inhibition. So now we say that it is, now we consider both competitive as well as uncompetitive, and we now come to mixed inhibition. So both factors both factors will now come into play. Remember, for competitive inhibition, we increased Km by a factor of alpha. So, here alpha comes. In case of uncompetitive inhibition, we lowered the value of Km by a factor alpha dashed. So, alpha dashed is also here. In case of competitive inhibition, we did not affect Vmax, but in case of uncompetitive inhibition, Vmax was lowered by alpha dashed. So, alpha dashed comes here. Here also alpha dashed comes. So, now how this equation changes? The equation I have just dropped those values of alpha and alpha dash, alpha dash, alpha dash. I will just rewrite the equation. It is like this: 1 by V equal to Km into ratio of alpha and alpha dash. Vmax lowered by alpha dash into 1 by S. Here 1 by S plus 1 by Vmax lowered by alpha dash. Now I'll simplify this equation. That is Km alpha alpha dashed into alpha dashed by Vmax into 1 by S plus alpha dashed by Vmax. Alpha dash cancels out. So, what remains? Km alpha by Vmax into 1 by S plus alpha dashed by Vmax. Understood? So, here here the point C is now increased by alpha dashed. The point C is now increased by alpha dashed. So, there if I consider if I now write the ordinates, this C, if this is for uninhibited A, then the value was 0, 1 by Vmax, but now the value of Vmax has increased by alpha dashed, like competitive. So, there is a definite migration of the point above. So, the new point for mixed inhibition is here. But for Km, you see, the Km value can be increased by alpha, can be lowered by alpha dashed. So, we do not, if it increases by alpha, we say that if the actual C by M value, that 1 minus 1 by Km value, if the Km increases by alpha, then what? That the point becomes more negative, that the point shifts by here, point shifts here. If the value, if Km is lowered by alpha dashed, the point shifts here. So, it is actually, if the point shifts here or here, we cannot say that. It will depend on the ratio of alpha and alpha dashed. So, when alpha equal to alpha dashed, we say that it is a particular case of mixed inhibition where alpha and alpha dash are equal and Km remains unaffected. Km remains unaffected. So, if these points are the line of no inhibition, the Km remains unaffected means the line goes above from here and it joins this line. It joins this line. But if the Km is affected, if the Km is increased or decreased, it can be both ways. In case of, if it is like uncompetitive, because it is a mixed inhibition, if it is like uncompetitive inhibition, the Km value will lower. In the case of uncompetitive inhibition, the Km value gets lowered, but if it is the case of competitive inhibition, the Km value increases. So, if the Km value increases, the Km value increases, we say that the point is shifted thisward, and with the Km value is lowered, the point shifts like competitive, this point shifts here. So in mixed inhibition, the point can shift here, point can shift here, but in case of mixed inhibition where the alpha and the alpha dash values are equal, that means a part of the inhibitor will bind the enzyme substrate complex, the other part will bind to the enzyme, the free enzyme. So it is both like 50% of the enzymes can bind to the ES complex, 50% of enzymes bind to the in the free enzyme. So it is both like competitive as well as uncompetitive inhibition, where in case of uncompetitive inhibition we know that the Km value is actually lowered. The Km value, the affinity increases, the substrate affinity increases and the Km value lowered, and in case of competitive inhibition we know that the Km value actually increases, that is affinity is lowered. So it is both like that. So we cannot say that mixed inhibitions the point will it can shift either ways, and if it is non-competitive inhibition, that is a particular case of mixed inhibition where alpha and alpha dash values are equal, then this is the case of non-competitive inhibition. Non-competitive inhibition where Km value remains unaffected, it is neither Km value, the Km value not affected, it neither goes above by alpha, it neither goes lowered by alpha dashed. So this is the case of non-competitive, the Km value is not affected, so the point remains here, and the Vmax is affected, and it is a kind of radiating line from the same point, from the non-inhibited line, it is another radiated line just to the left, another radiation of line just to the left. Okay, so you will have to remember it like that. So these are the three types of inhibition and their double reciprocal plots that I have just completed today. You'll in the next class I will explain this a little bit, a little bit intricacies about all these inhibitions in a little bit details. Now I conclude the class, and I hope that you will remember all the intricacies that I have told you, all the subtle points that I have told you, how Km increases, how Vmax is lowered, how Km in case of the values Km and Vmax, these are the very important parameters of enzymatic reaction, Km and Vmax, how these values increases with different types of increases as well as decreases with different types of inhibition. So I will conclude cheering you up, don't get bogged down, just complete this whole thing in a single go, so that you remember the whole thing with all the logics. So happy learning, be brave enough to learn the full thing in a single class, anyway in a single sitting. Thank you for patiently hearing to me, and so our journey of this inhibition, enzymic inhibition ends with this, and thank you and goodbye.